What was the follow up to that? And so the
Okay,
company
so
name inspired by Group A.
Megacycle makes me these cams. They're working and they're winning races overseas. At this point, I still don't know anything about camshafts. I just know what camshafts are, and I know a way to make them survive using Megacycle's knowledge, right? But because I saw what kind of power they're making, I said, okay, well, Jim, he's the owner of Megacycle. It's like, can you design me a profile and I'll make it into a production sort of street performance cam? And we use the same technique on that, where, but instead of welding two lobes and grinding out the middle, he welded up three lobes and we ground a complete VTEC cam. That was in 1997 and 98. I'll show you the first. I don't have one that he hard faced, but I can show you the performance that it gained back in those days. First B cam dynograph. So that red line, the stage one cam, that was essentially the first prototype cam that Megacycle had made, and that was like 12 horsepower. That's a lot of power back then, right? Like cam swap, very few other changes and make 12 horsepower. Right. So when we tested these cams, there was no Honda cams in the market back then, other than the Japanese manufacturers. By yeah, no, actually, I take that back. So Toda was already making cams back then. June was making cams. I don't know any other people that were making Honda cams at the time. So after we made these prototype cams, I'm like, okay, well, how do I make it? How do I make a production cam? And this is where I learned lots of stuff. It was a trial by fire, um, because, like I said earlier, the steel cam doesn't like to rub on that chrome rocker pad. It'll destroy itself in minutes. It's not even not very long. It'll just completely wipe itself out. Um, so for me, it was like finding a manufacturer who could make the camshaft that would survive the Honda rocker. And then every manufacturer that I asked, they said they could do it. That's kind of the standard issue, right? Everybody says, I can do it, I can do it, I can do it. And then it's sort of like, they make me a prototype and I test it and it like fails. So I tried a bunch of materials. I tried gray iron. I tried, geez, well, here's another story of how this cam came about. So I tried a bunch of different materials, and none of them were lasting. They were all failing, and they were failing very quick and very complete. So it just happened to be at that time, this guy. I don't know if I should mention his name because he's like, this company still supplies other cam companies in the industry. But this guy who had a factory in Turkey, he came up to me and said, "Hey, we can make you these B cams." Jay's shaking, like nodding his head. He probably knows who I'm talking about, right? He said, "We can make you these B cams, and we can make them out of steel." And I'm like, "Well, that goes against everything that I've learned so far. It's like, how are you going to make it survive with steel?" And he was like, "No, no, don't worry. We got it. We figured it out. We can make it work out of steel, right?" And so I'm like, "Okay, well, if you're willing to guarantee it, I'm willing to try it." So he guarantees it. We made, I forgot how many cams, maybe like 50 sets of cams initially out of steel, and he delivers them to me. They look nice, and then I put them in, and they just failed. I'm like, "Well, you told me they're gonna work." And then, like, he was just like, "Yeah, well, like, they're supposed to work. I don't know what happened. It, it's been so long. I don't know the reasons why they gave me." But I'm like, "Okay, well, I got 50 of these steel cams. How hard can it be to get these things to survive um, these rocker arms?" Right. So I started experimenting with different things to try to get these cams to survive. And that's really kind of where I started learning a lot about uh, heat treatments, physical vapor deposition, like PVD coatings. super finishing, different things like that in order to get the cam to survive, right? And I actually got it to survive. This was like a first skunk production cam. It was a steel blank, and then it was super finished, and then it had a chrome carbon nitride PVD coating on it, and it survived. We I put lots of hours. We did a lot of road testing. We put thousands and thousands and thousands of miles on the car just to because it already failed one time, so I was worried that it was going to fail again, right? So I had to put a lot of time on these things. Well, this set that we did like this, it worked out. It passed our validation. Okay, so then I'm like, okay, now I just got to do it to all 50 camshafts, you know. And when we did it to all 50 camshafts, so one really important thing is the finish has to be super fine. In order for this coating to work, you have to have a super finish on it before you put the coating on there. And when I got the camshafts back, it was clear that they shortcutted the polishing part because the surface wasn't as smooth as it needed to be. It was certainly wasn't even anything close to the camshaft that I have pictured here, right? And the manufacturer's like, oh, it should be no problem. Well, that was wrong because as soon as we put it in the engine, that rough surface with a super hard coating on it was just like a file. It just completely sawed through anything the camshaft was in contact with. The surface was great. The camshaft survived, but it just destroyed everything else, right? So that was like, here, let me go back. It's funny. So my first B camshaft ended up in a recall.
And back then, what was the super finish treatment called? Understanding that back then, probably the REMs didn't exist. What was it labeled as for these finishing techniques?
REM did exist back then. I didn't use REM. I actually used like polishing wheels because they have camshaft polishing, super finishing rigs. Um, but yeah, REM was pretty new back then, and even super finishing was pretty new back then. But like if you want a nugget of information and you're going to use steel cams and you want to do PVD coatings and things like that, just make sure that the surface is really smooth. Otherwise, it's just like if the surface is rough, you're creating a rotary file.
Give the starting line advantage right there, too.
How much did it drive the cost of the unit up by the time you had to work through all this additional? Was it just because you were too proud to throw stuff away that you continued down the road?
Well, fuck, I had no options at that. I'm like, what's my option? This guy came to me with a solution, and it ended up not being the solution. And then he was willing to actually cover all the costs to do all this refinishing, right? So it was the refinishing vendor that really just kind of screwed it up by not polishing it right. And so I ended up recalling this first batch of cams. And if you look at on the screen there's some, it's funny, you got some names you probably recognize.
Oh yeah.
Yeah, so that first batch of cams, I ended up having to recall 20 units that went out into the field. But if you listen to the internet back in those days, it was just like, oh, they sent out thousands of cams and screwed all these people or whatever. But it's like that's hardly the case. It's like the internet has a way of amplifying the misinformation. Okay, so while I was working on fixing these billet steel cams, I had somebody else approach me overseas, and he was actually an engineer that was responsible for the initial sample inspection approval guy, and so he knew all of. He had a big Rolodex of people that he could use to do camshafts, and he was just like, "Oh well, I have a guy. It's like I can make you the cams. They need to be chill cast." It's like, what's chill cast? It's like I had no idea what's the difference between chill cast and regular gray iron casting and things like that. Are you guys familiar with? We hear the term chill cast a lot. Are you guys familiar with the concept of chill casting?
Um, in the Jay Z world, they seem to live a whole lot better than the steel cam. Um, and what I know about chilled casts is that there's not a lot of places in the world that do it. So you can't just go around the corner and find a new guy if the other guy is dragging your supply chain out.
Right. Um, I'll have you take a look. You'll see. Do you see these lines?
Oh yeah,
What I found when I used to say chill cast, people would think that somehow it's chilled in a refrigerator or it's frozen or something like that. But when they say chill, it's actually the relative rate of cooling is so much higher where there's the chill, which sits on top. I'll do a little diagram to explain that. But this area cools faster because there's actually a piece of metal that's inserted into the mold that draws the heat out of the molten cam faster, so it hardens, right? So we know that the faster you cool something off, the harder it gets, essentially, right? That's like a basic uh, material science type of thing. So if we had a so this is a mold, right? This would be the drag. This would be the coat, and you end up. So this piece in here is called the chill, and that basically, as it's cooling, it's sucking all the heat out of the lobe as quickly as possible. And then what ends up happening is you get this hardened case, and the shape of this case and the thickness of the case is determined by the size and the shape of the chill, right? So the chill could be like this too. It could be all sorts of things. Does that make sense?
Yep.
yeah, I can follow you.
Okay. So on a chill cast thing, this part turns into white iron. So this is gray iron, and this is white iron. I think that they also call it cementite. And what it is the white iron's essentially carbide. That's why the chill cast lasts against the steel. Like so on a 2J, you have a bucket which is made out of steel. So by default, the correct material for it without coating or treatment and things like that is chill casting. And that's going to be the same for anything that's on a steel tappet. So I believe Subarus also have steel tappets. Sometimes, sometimes you got the bucket and it's got that disc on top.
Yeah, the shim.
If this shim is chill, sometimes these are chill cast.
Did you know that the majority of the Japanese JZ engines they coat that shim in a tin coating, but the
Uh,
U.S. market engines didn't have it?
I didn't know that, but
Yeah,
tin coating would not be anything that is modern. You know,
no, but it seems to work. The cams always come out looking very, uh, just pretty and polished.
so if this shim disc is made out of chill, then you can run a steel. You can run steel on it. But if this is steel, then the camshaft needs to be chilled. It's pretty simple. And
Yeah.
so if you have other like your 2J stuff, I would start by probably like are you having valve train wear issues on the 2J stuff?
It seems like there's a bit of maybe I don't want to say greed, but aggressiveness, and you're starting to get some guys like if you have a steel cam on a steel bucket, you can make a mess out of some stuff. The more aggressive the cam, it's like as it comes into the take up ramp, there's a horizontal line across the lobe. I could send you a picture of it. And sometimes that will start dragging that steel up to the just about where your S starts on your little picture there, and then it will become a cutter and you'll destroy buckets. Um, the chilled cast cams, um, depending on how aggressive they get, I see that same stamp if I look real close on the camshaft, but it doesn't have the same negative effect on the bucket. It's harder. Seems like it's a lot harder to hurt parts with a chilled cast cam than a steel cam. I've used steel cams um, with a DLC coated bucket, and that's worked out okay. But this is going back almost a decade, where it was hard to get people to want to spend the money on the coating compared to just running a regular bucket.
Right.
But you also like the harder you accelerate the valve, the more likely you are to destabilize the valve. The more you got to have your act together on the valve spring program. And unlike the Honda, we don't have a lot of because of the bucket diameter and because of the installed height, none of these JZ engines are like high lift engines. But
Yeah.
you can still screw one up. There's still a mess to be made if you get after it too aggressively.
With the flat tappet stuff, the cam on bucket, the limiting factor is the valve velocity. If you go too fast, then you'll hook like if the velocity exceeds a certain limit, then you'll hook the edge. You'll hook the edge of you'll start grabbing that edge.
Yeah, and you can see that on some of the cams. You can see that that's happening. I have a cutaway cylinder head, and I'll put a camshaft in a cutaway cylinder head, and just like kind of like just take a crude look at how it interacts with the bucket or lifter. And some of these really whack that corner pretty good. And after you run the cam for a period of time, you could see that. Now, in a drag race only environment where the engine may live for 20 passes, maybe you take a little bit extra aggression in the valve train because if you could stabilize it, it makes more power. But for guys that don't want to work on their stuff all the time, I just try to stay more conservative in the valve train.
If I was to take a look at that problem, then I would first of all look at the camshaft, measure it, see what the velocity is, and then do a calculation based on the diameter of the bucket. And that would actually tell me if I'm exceeding it or how close I am to running to the edge, right? If you're hooking the edge, that's bad. That's just bad across the board.
Yeah.
So you mentioned like chill casting. It's hard to find people that do chill casting. Well, you are right. I ended up finding a factory, and I'll actually tell you what factory it is. It's this company, Riken. Okay, they actually made industrial parts for like Japanese Zeros and stuff like that. They have a long history in industrial stuff, right? And then if you look, they combine with NPR. You should know, like the NPR steel rings are standard steel ring base at this point, right? So the NPR and Riken, they ended up combining, and then you could see like they have so many factories that could do chill casting all over the world, right? I mean, some of them are probably rings, some of them are probably camshafts, but okay, so like I know for a fact that they can do chill cast camshafts because I've used them.
Right.
It's interesting because there's nobody that really does chill cast cams here in the United States. I have yet to find one that's willing to do this type of stuff. In Asia, it's becoming more common knowledge. So you get a lot of the Chinese foundries and things like that. They've the technology transfer over the last 30 years. They've figured out how to chill cast. So there's a certain democratization of that knowledge and the process, and I think one really important thing to understand is like this is the '90s. There's no fucking internet.
Right. It was a different time to get anything done.
Right. Who are you going to ask? You know, it's literally the luck of knowing somebody who knows somebody who actually has the right answer. But in this day and age, you know that the people that actually have the right answers are few and far between.
Yeah.
So it's easy to get taken for a ride. You know, you could say my first camshaft failure project, the recall, was I didn't know better. I was 20 something at the time. So that's why, people are like, hey, I want to show you your cams suck, and they throw it off of a roof.